Hello everyone, this is Keshav Peswani and I'm back with a new chapter in the database learning series. Continuing from our previous lecture wherein we discussed about the CAP theorem, I would like to take this further ahead and into the new chapter which is SQL versus NoSQL. In this world of databases, there are two types of databases which is SQL and NoSQL. The SQL database, as it suggests, it's a structured query language and it's a relational database wherein the data is structured and there is the scope of only horizontal expansion. That means the data is in a relational format plus horizontal expansion. When I say horizontal expansion, I mean that only once the database has reached its capacity, then you need to create another database. But in the world of NoSQL, it can keep wide variety of database. So NoSQL, you can have wide variety of database or data, plus it gives us the horizontal scalability option. When I say horizontal scalability, it means that you can add more and more nodes and the data can be distributed among those nodes. So there is one database, but you can keep on adding more and more storage to the database. Whereas in the horizontal expansion, you cannot add more than like a particular limit to a database. Like you can, let's say in a SQL database, you can add maybe 500 gigs or 1 TB of data and then it will start slowing down. So you need to add one more database. You can't horizontally scale the database but expand into multiple databases. Now let's try to understand what are the properties of both SQL and NoSQL databases and how they are different with each other. So let's start with SQL database. So SQL database, as we know, it consists of relational data. So that means there is a structured data harmony in it, and the tables or the data in these tables in the SQL database have a relationship or can have a relationship with each other. It follows the ACID properties. When I say the ACID properties, it means that it should have atomicity, consistency, isolation, and durability. What I mean by atomicity is either the transaction goes through or there's nothing that goes through. Let's say if I have a table or if I have two tables that need to be updated in a transaction, either both of them would be updated or none of them would be updated. Consistency, as we have already seen in our previous lecture, that consistency means whenever a question is asked, you'll always give back the correct answer.
That is consistency. SQL databases follow rigid consistencies. Now coming to isolation.
Isolation is whenever, let's say, there are two transactions that are happening in parallel. So that means two transactions are happening in parallel. If one of the transaction has an error, so one of the transaction fails, the other transactions can still go through, or vice versa. That's isolation. So that means one transaction does not impact the other transaction. The durability in this case is that once a data is committed, it is backed by backups and it is backed by the commit logs. So that means the data is never lost. So that is durability. SQL database also allows us to do complex joins and transactions. So transactions are definitely one of the major properties of the SQL database, and complex joins, since it's relational in nature, it allows you to do a lot of complex because the data is related with each other. So that's the complex joins and the transactional property of a database. The SQL database is only vertically scalable. That means, let's say if I have a database that has 2 CPU and 4 GB of RAM with, let's say, 500 gigs of storage, I can increase this value or this value to be like a 8 CPU and 16 GB of RAM. But this still becomes in a single node. So that is one node in it. There cannot be two nodes. Yeah, there are ways to do this two nodes wherein you do a partitioning of the data and the entire partitioning logic needs to be handled by the client. But in case we don't want to have these complexities, then it is only vertically scalable in this manner. The use cases of this SQL database is when there are relationships in the data. This is very important, that the data needs to be in a relational format And there are various databases, which is MySQL, Postgres, and SQL Server. Now coming to NoSQL databases. NoSQL actually stands for not SQL. They actually follow the base properties instead of asset properties. So base is the right thing, but they don't follow the asset properties as opposed to SQL. Base stands for basically available. S stands for soft state, and E stands for eventually consistent. These three things are actually derived from the CAP theorem itself. So when I say basically available, if the data is there in the database, it will be available and in some time. When I say soft state, since we don't have the rigidity in the database, in the NoSQL databases, it has soft state. You can store any kind of data. And eventually consistent is once you stop sending the data, eventually it will be consistent. That means it will give you the right answer every time you question for it. So these three properties actually are derived from the CAP theorem itself. There are 4 different types of databases, which is key value database, which are basically simple key and values like redis. You have document types of databases like mongodb. You have graph DB, which is like Neo4j, and then you have a columnar databases, which is your Cassandra. So there are 4 different types of NoSQL databases. Let's see what are the properties of these NoSQL databases. Since they don't have that much rigidity, so their schema is very flexible. That means you can enter any kind of data that you like to in the NoSQL database. It follows the CAP theorem dynamics. As we saw earlier that they follow the base property, it's derived from the CAP theorem. It can store data in various formats. It's just not the relational format, but it can store data in the JSON format or in document store like MongoDB. It can store data in a very complex document, which can be in the form of JSON or a BSON. And in graph database, it stores data in a form of entities. These entities are nothing but nodes, and then there are relationships between these nodes. That's similar to how graph functions. And the most important thing in this is the horizontal scalability. In the NoSQL databases, you can horizontally scale. That means you can ingest huge variety of data at a very high scale and at a very high traffic. That helps in the demands for scalability, handling vast volumes of data, and supporting real-time applications. These real-time applications will be like ingesting sensor data. That can be one of the real-time applications. Like there are multiple sources of sensor data that are sending the data, and you have to ingest it for various use cases that can be ingested in a NoSQL database. Now that we understand their properties, let's see what is the difference between SQL database and a NoSQL database. So the first difference and the major one is the scalability. In a SQL database, you can only do a vertical scaling, but in a NoSQL database, you can actually do horizontal scaling, which means when there is a need to scale up your database, you can actually add more and more nodes to do a horizontal scaling. So the second difference is the consistency versus flexibility. The SQL database is more rigid in terms of its consistency since it follows the asset properties, whereas the NoSQL database is eventually consistent. You can ingest data at a much higher scale and at a much flexible format that helps it to be more flexible and more better choice for ingesting of this data. The third thing is the ease of development. Since it's flexible, NoSQL database provides more developer-friendly environment in the initial phases of the project. But as and when the data grows, there is a huge maintenance because you have to maintain a big cluster, and that's where the NoSQL database becomes more maintenance heavy. Now let's try to understand which database is the right fit for your project. Though it depends on the needs of the project, there are 3 major factors that you need to take care while considering whether you should go with SQL database or a NoSQL database. The first one is the data structure elegance. So when I say data structure elegance, we need to see the nature of your data, which means whether it's a relational data or a non-relational data like a JSON or key value pairs. The second thing is the scalability. Do you anticipate the scale of your database to increase? When I say scale, it doesn't mean that it will increase in one day. It can increase over time. But do you anticipate the data to increase in a manner that cannot be handled in a vertical scaling? In that case, you should always go with the NoSQL database, because that's where you can actually scale up your database in a horizontal manner. And the third thing which we should consider is the data querying capability. The SQL database is preferable to help you out with the complex queries. So that is very important. Whereas a NoSQL database can only help you to query data in a partition tolerant format. That means only the partition keys or the keys which are made as a primary key or partition key can be queried. Otherwise, if you query any other key, it needs to scan through the data. Since we are talking about horizontal scalability, it needs to go through a lot of nodes and scan the data. So that's where you need to see what's your data querying and what is your capability or what's the demand of your project. So overall, choosing the right database is very important for the success of your project. The choice that you should go with SQL or a NoSQL is actually an artistry. It comes with experiences, and there are various pros and cons of using SQL versus NoSQL or NoSQL versus SQL. But my experience has been that ensembling of both SQL and NoSQL actually helps a lot in longer run. So anything that is relational can be kept in a SQL manner, whereas anything that is not relational can be kept in a NoSQL manner, and the data can be queried from both sides of it. So there can be one service that can query data from both and give you the response. So this was the differences between the SQL and a NoSQL database. In the next lectures, we'll start learning about what is a SQL database, what are the properties, and what is the architecture of this database. And in the further lectures, we'll also understand what are the NoSQL database, different types that we discussed, like the key value database, the document type of database, the columnar database, and the graph database, and the choice for these databases. So stay tuned. Happy learning.